again continuing on reverse engineering and finding all of the hidden functionalities for the Casio PT180.
So you've got CPU matrix sort of mapped out. Those are the east and the west lines that we were probing.
Correct. So we know that based on this sheet that we just filled out last video, we know that the 13 lines of the keyboard are associated with certain east and west lines, and the 19 lines of the user input board are associated with a certain number of east and west lines. And so of course there's going to be shared ones here. And so what I'm doing right now to make it easier on us is just figuring out which tap points we can use.
So instead of using the 1 through 13 and 1 through 19, you're now translating that all the way up to the CPU, the source of the river, if you will. And
we'll reverse, actually. Reverse. Because right now I have all of the CPU spots, but I'm trying to give you tap points that are in the 1 to 19 and 1 to 13, so you don't have to touch the CPU.
Yeah.
Yep.
But the matrix, that sheet, is seeing what happens when we connect like west 7 to east 5, for example, right?
Right. Yep. So let's take a look at W12, and essentially I'll just show you guys a couple of these, and then you can do your own associations. But West 12, we can either use keyboard 11, or we can use user input 12. I'm just going to use, user input 13. I'm going to use U13 because the majority of items that are connected to the CPU are available or are accessible via the user input. So it's just easier for Whisker to tap on just the user input lines rather than having to go between user and keyboard all the time. And
electrically, they're exactly the same wire, so.
Right, they're connected to each other. So then W13, we can either use K10 or U2. So I'm going to do U2. For W14, we can use K9 or U3. So we'll do U3 here. 15, we can do K8 or U1. W16, K7, and it doesn't exist on the user input, so the only one we can choose is K7 for this particular line. And then I'll do the same thing up here, and then we'll have the points that we can tap easily.
Okay, and these are the ones that just exist on those headers. We also found those 2 extra lines on the west side of the chip that look like part of the scanning matrix.
Yes.
So are we going to add those to the matrix?
We can do that. So West 17 and West 18.
Just to see if anything is there.
And the reason, if we look at the probe map that we did before, this is obviously a little bit more filled out. So we're looking at West, and we know that there are connections here. If we look at this West 7 through 16, West 7 through 16, so these are the way I've denoted that there are signals on those lines, and you'll notice that 17 and 18 we also found and probed that there were signals on those lines. So we decided to take a look at those just to see if maybe there was hidden functionality. Okay, so we're going to finish this up. U4, U5, U9, U8, U6, and U7. All right. So, we're gonna do some basic connections. We'll do some basic connections, just looking at functionality that we know should exist.
Like the lowest note on the keyboard.
Right.
Okay,
Okay?
let's set up to do that.
Okay. All right. So we've got everything set up here so that we can start filling out this matrix. And so let's go ahead and just start with what we already know is the lowest note.
I'm just going to use a jumper that has male ends on it.
Yep.
And the lowest note on the keyboard, when the plastic keys are above this, that makes these connections, the lowest note would be here. So if I connect the top and bottom of this switch to each other directly, which is what the NPN8 does in the big project, just uses a transistor instead of a jumper, that plays the lowest note on the keyboard.
Okay. So let's try K7 with U4.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Same note.
Okay. So that one's going to be note 0. That's going to be F1.
This is the goal for our project, is to be able to figure out what to hook together here to pretend like that got pressed, right?
Right.
So,
Okay,
yeah.
so try U1 and U7.
Okay, U1, 2, 3, 4, 5, 6, 7. Higher note.
Okay, and that actually is F#1. Okay, and then U1 and U6.
1, 2, 3, 4, 5, 6.
Okay,
So those are like the first 3 notes down here.
correct.
Gotcha. Check them. Yeah, they sound the same.
Huzzah! So we're gonna go ahead and I'm gonna fill out what this keyboard automatically has, and then we're gonna show you how we went down the rabbit hole from there.
Yes, once you get the things that we know about, these 4 switches, these 2 switches, and these switches that we did a couple videos back, it exposes holes in the matrix, and holes are exactly where we want to go looking for treasure, right?
Yep. All right, so I'll do that and then we'll be back.
Okay.
All right, so I've gone ahead and filled out all of the elements that we know we have on the keyboard. So you'll recognize these 6 switches from the user interface board, and then these are going to be the switches on the actual keyboard. Now it looks like we have quite a few empty spaces, and my guess is if we were to connect K7 or West 16 to all of these other spots, we might actually get some notes. So why don't we go ahead and try that. K7 and U5.
And the note that is close to that area is the F1, right?
Right.
So I'll play that real quick so it's in people's head. So that's that tone. And which 2 do you want me to get?
Let's do K7 and U5.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That's lower.
Yeah, it is. Okay, and then still K7 and U8.
Okay, there's K7. 2, 3, 4, 5, 6, 7, 8. That's lower yet.
Yep, D sharp on that. And then K7U6.
6. Lower yet.
Oh, did I skip something? I think I might have skipped something. Try K7U9, sorry.
2, 3.
Okay, that's D sharp, got it. Okay. And then K7U8. K7U6. K7 and U7. So these are notes that aren't normally on this keyboard, but that we're finding out just because these lines exist.
Haha.
Yeah.
And they probably use the same CPU on multiple models, some of them which had bigger keyboards, like physical keys. More keys on the keyboard, but it costs a lot to manufacture one of these chips.
So they just...
So if you can reuse the same chip on multiple models, that's more cost effective.
Right. Do we want to keep looking at... So now W17 and W18, those extra lines that we didn't necessarily know what they were going to do.
Oh, these up here.
Yeah.
So the
should we
yellow
try
one
connecting those?
here is 18, West 18, and this one is West 17.
So let's do West 17 and go U4.
Let's see if I can reach it here. West 17, U4.
Yep.
1, 2, 3, 4. Okay, so that's a lower note
Okay.
on a CPU line that wasn't even connected to anything on the PCB.
Right. And let's continue. So West 17 and U5.
Mm-hmm.
Okay, West 17 U9. West 17 and U8. U6. U7. Okay, and then West 18.
Okay, and that's that yellow one.
Yep. Okay, so let's go U4 once you connect. E? Sorry, I'm just giving the answer. U5. Okay, U9. Okay. U8. U6. U7. Nice. So we managed to get a whole extra octave and a half just from kind of guessing that some of these missing holes would have extra information. And so of course you see there's a whole lot of other holes that we can look at within this matrix, and that's kind of the fun part. And so what we did was filled it out. And what we were able to find, actually, it was kind of cool. We were able to find some test tones. Did you want to do the test tone?
Sure.
You might have to power cycle things, though.
Yeah, it won't stop once you start it. Where was it?
West 17.
Okay, so that's the blue one up here.
Yep. And U11.
Okay, West 17, U11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it won't stop.
Yep. So we got power cycle that.
Mm-hmm.
All right, and then we can start stop demos or start stop.
Okay, so the demo on the Casio, what model is this?
PT180.
PT180. A lot of those toy keyboards have like a demo button on them that you can press in the store to hear what sounds it makes. But this keyboard did not have a demo button.
Correct.
But we found the demo button.
Yep.
All right, so where?
West 18 and
Okay, so that's
U11.
the yellow one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And it also works.
And I can stop it. Yeah.
And then we also figured out that West 7 is where all of the changes to instruments are.
Mm-hmm.
But we noticed that there were two instruments, the celeste and clarinet, where you actually had to add
Three wires
lines
together, yeah.
Yeah.
Well, 2 pairings, but they share one of the I/O pins.
Right. So then to select celeste, you would have to add U14, U6, and U10 together.
Which I don't have enough fingers to do, so.
Right. So, but just to explain what that means here on this portion of the spreadsheet here. So, yeah, this was fun. So we got a lot of extra functionality here.
And the X's are still there, and those probably do things. We just haven't figured out what they do yet.
Correct.
There's been some rumors about there being hidden chords, and there's been some rumors about some of these Casios having a sustain on and off functionality, like a sustain pedal. And I'd like to find those. And sometimes on these keyboards you can trigger the different drum sounds. I'd like to find those, but we have not had any luck finding any of those items on here, on this particular model.
Yep. But from here, we essentially might do a probing of the rest of the CPU just to see what's going on, since we're already finding so much extra functionality, to see if we can find anything else.
Oh yeah, we were going to do the all these lines here.
Yep.
Show what sounds are coming out of the south side of the chip.
Yep.
That gets into the really weird stuff.
Yep.
But I think we're out of time on this particular clip.
ProtoSynth MIDI, ProtoSynth MIDI Lite, and all compatible modules are available for sale at tindy.com/stores/TYMKRS, and in-depth technical information about this and all of our products are available at tymkrs.com.